Hello everyone, you are welcome to the Don's Consult. And we know that students in FCT, Abuja, Nigeria, they are preparing for a pre-WAEC exams, which is called mock from the Educational Resource Center. Information reaching me for the practicals is that for the qualitative analysis, these are the sorts that will be analyzed. And if this is true, these sorts, when they dissociate, we know we are going to have zinc 2 plus, we are going to have CO3 2 minus, possibly going to have CO2 gas, and of course we are going to have Na plus and chloride ion. These are possible things that you'll be asked. So as a good student, you have to go and find out possible reagents to getting these, the observations and their inferences. Well, as a tutor and a coach, and trying to make you have excellent results, I've gone into the lab, I've done research, and I've come up with results for you. And this is the results. All right, so this is what we have. Okay, so these are the possible things you'll be asked to do. Well, we'll have this sample mixed with water. They may ask you to have the sample itself or the physical appearance of the sample, under that the observation is sample is a white powder. They can ask you to add water, and when you add water and stir, you are going to observe that it will be insoluble salts. All right, and when you filter, you are going to discover that there will be a white residue and a colorless filtrate. And what is the interpretation of that? That's the inference. That will be the mixture contains both soluble and insoluble salts. This is so because some of it were dissolved and some weren't dissolved, and that what gave birth to the filtrate and the residue. All right, you'll be asked to divide the filtrate into various portions, and to the first portion or whatever portion they say, you could be asked to add sodium hydroxide into one of the portions in drop wise and then in excess. If you do that, painstakingly, you are going to observe white gelatinous precipitate, which is soluble in excess. And what does that confirm, or what does it connote? White gelatinous precipitate in sodium hydroxide tests the presence of any of these three ions. All right, and to get the very one, they will ask you to add sodium ammonia to what you have done here. All right, to this continuation of these. All right, and if you do that, you are going to discover that, or they could say you should mix the filtrate with sodium ammonia, aqueous ammonia in drops and in excess. And if you do that, you are going to observe white gelatinous precipitate, which is soluble in excess, aqueous ammonia, to form a colorless solution, and that confirms the presence of zinc ion. So you write zinc 2 plus present. All right, and you could also be asked from the portion of the filtrate, you should add dilute HNO3, dilute AgNO3, and ammonia solution in excess. So you take it one after the other. Right on the first line, filtrate plus dilute HNO3, you observe that there will be no visible reaction. You put a full stop there. Then under it, you put plus AgNO3. When you add AgNO3 to this substance here, you are going to discover a white precipitate. You put another full stop, then you come to add your ammonia. And when you add ammonia solution in excess, you discover that the precipitate dissolves in excess ammonia. And that confirms the presence of what? Chloride ion. So you write under inference Cl minus present. All right? Then I think that should be all for the filtrate. And from the residue, you could be asked to get a portion of the residue and mix it with dilute HCl. So if you do that, you are going to discover an effervescence or you see a bubble, all right, we call it effervescence evolved. And when effervescence evolve, what does that mean? It means there's a gas. And what type of gas is that? It's a colorless, you observe, an odorless gas, which is neutral to litmus, and it turns lime water milky. Any gas that does this is a what? CO2 gas. In this case, you write CO2 gas from CO3 2 minus present. Sometimes some scholars will ask you to write CO2 gas. CO2 gas. This is a gas. CO2 gas from CO3 2 minus or HCO3 minus present. However, all right, what they want to see, that CO2 gas. So the next one, you could be asked to get residue and heat, which I did to observe residue turns yellow, and when it was cold, slightly cold, the yellow color turns white. So I wrote residue turns yellow and white when cold, and that confirms the presence of zinc oxide. Should you be asked to test for zinc oxide? We don't know what they are going to ask, and some of you that have been following my channel knows that we give more than 90% accuracy in our predictions. And you could be asked to do a flame test of this residue, and if you do that, you're going to discover an intense golden yellow flame, and that confirms the presence of sodium ion. From all what we have done, you discover that we have sodium here, we have CO2, we have chloride, we have zinc. So you can come at the end of your analysis, write sample, whatever it is possibly a mixture of sodium chloride and zinc carbonate. There will be extra mark for writing that prediction at the end. All right, so that is for the qualitative analysis. All right, I also have a prediction for you on volumetric analysis, which is your titration. I have two predictions. I want to put all of them together on this video just for your sources. Whatever the question is and however they put it, they give you 5 grams of H2SO4 per dm cube, and whatever story it is, as you have here, solution B to contain 8 grams of impure potassium hydroxide. Anywhere you see impure, just know that they could be asking you for percentage purity or something somewhere. So I got 3 questions, like molar concentration of the H2SO4, to calculate the molar concentration of potassium hydroxide, and to calculate the concentration in gram per dm cube of potassium hydroxide in solution B, and hence find the percentage purity. And this is what I got. You can have this, you can screenshot this and write it out. Make sure you have your answers in 3 significant figures, and put up right units. All right, right units. So you have this, right? Good. All right, and the second one is when they give you something like this, an unknown base, which is a solution Bn of this, containing whatever they give. I decide to put 6.5 gram per dm cube of blah blah blah. Is that right? And solution An of H2SO4 contains 0.06 mole per dm cube. Don't be carried away when you are given this. You have to observe the question very critically, and the question says that you find the concentration of SOH in mole per dm cube, molar mass of SOH, and the atomic mass of X. Some students will jump to using the formula that we have, molar what is it called, molar conc equals to mass conc over molar mass. No, you don't know what the value of X is. So that's why they gave you something like this. So come to use the common one that we have been using, CAVA, all right, to calculate the concentration of the base in mole per dm cube. All right, after you have balanced your equation to get ratio 1:2 of acid to base, then you now use this formula, molar mass, for your solution 2 to get the molar mass of the SOH. And when you have done that, you now use that to find your atomic mass as it is put up here. Very simple, very simple. This is what we do here at the Don's Consult. We are just here to help you score that distinction you crave for in your exams. And I want to wish you well. If you have any question or any comment or whatever you want to suggest or ask, please go to the comment section and like this video. Please share and recommend this channel to all your friends. Thank you. This is the Don's Consult. See you in another video. Of course, that will be to prepare you for your WAEC, which you are going to see through this how accurate our predictions is. Bye for now.